Hey, welcome back. Today on my bench, I'm not going to be doing any repairs today. I got something a little different in mind, and I just want to talk first a little bit about it. I've been thinking about doing a project here for a while now, and been mulling it over for the last 6 months or so on how I'm going to put this project together, and I think I have it all worked out in my head, and I'm starting to actually lay things out on paper and see how things are going to fit and how it's going to work together. So it's actually looking very promising. But I want to share with you what I'm thinking of doing. I'm looking at building a piece of test equipment called electronic load. And I've looked online for electronic loads. They do sell them. HP, Allergent, few places make electronic loads for the lab, but they're pretty expensive, and I'm looking at them and say, well, for what you get for the money you're paying, I just don't understand the reasoning why it costs so much, especially if it's just electronic load that you want to use for testing power supplies. That's mainly what I want it for, is just to test power supplies after I repair them. I want to load test them and make sure that they're all good. Maybe even do burning in if I have to. So I got looking at a few electronic loads online, and I wasn't even liking what I saw from the commercial units. So I decided to go ahead and try and put one together myself. And I was on AliExpress one day, and I looked and I saw this here. This is electronic load. It's 150 watts, 10 amp constant current electronic load, and it's a printed circuit board. I do have it here. Let's pull it out and look at it. Now, I didn't pay $18.92 for this. I paid something like $10. I don't understand why. I printed this off yesterday. I don't understand why the prices have escalated so much. But it's a kit. You get the board, you get all your components, enough to build this 150 watt 10 amp electronic load. It comes with a 10 turn potentiometer for adjusting your current. Comes with a nice printed circuit board, double-sided. It's run on an LM324 chip, and it's pretty basic. You can have running off here 4 MOSFETs, and the MOSFETs they give you, let's see here, they give you all kinds of stuff. They give you these MOSFETs here, and these, I can't remember what they are rated at. I looked them up. I think they're 16 amp or something like that. I don't know. I have MOSFETs here, great big ones, and they're like 30 amp MOSFETs, so I can scale this up or do whatever I want with this. I don't have to stick to this 150 watts. I can make it beefier if I want to, and I think I might, because you get a computer power supply and it's got 500, 600, 700 watts. Output. You want to make sure that the supply is going to do that. So one of the things about my electronic load that I want to create is I want it to have 4 channels, because all the commercial units I looked at usually had 2, and that's not going to be enough. I want a minimum of 3 channels, but I figure why not just put 4. So that's what I'm going for. I bought 4 of these, and I partially assembled some of them, and I think some of them are still, this one here is not assembled yet. Oh yeah, it is. It's got a little bit of assembly done on that one. So I got the boards, and these are, just off the top of my head, they're 4 inches by 4 inches. So I'll need 4 of these, and then I'll have to figure out heat sinking. Heat sinking won't be a problem. I'll just grab, I got heat sinking here in my scrap bin. I can use something like this. It's a little long, so what I can do is I just cut it in half and use it as two heat sinks, and I'll use one heat sink for each 2 loads. And if that's not enough, I'll get more heat sinking, but this should work. and then I'm going to get it fan cooled. Now I want this project to be built the way I envision an electronic load to be. Something that I can attach a load, a power supply up to, turn it on, and dial in the current draw that it will take. And then what I want to do is I want to monitor each channel. So I also got myself 4 of these, and these are just El Cheapo voltmeter, ammeter, wattmeter panel mounted meters. So let's see if I can pull one out. I got them kicking around here. Where'd it go? Yeah, here it is. So here it is, basic Chinese unit, and you run your current through these 2 wires, your current sensing, and then this here you got black and red, that's your power for the voltmeter, and then this yellow wire is your sense, your voltage sense. So this will tell you exactly how many volts this is. So I'll have one of these for every channel, and they'll all be independent from each other. So I'll have the electronic load with heat sinking and MOSFETs, and I'll have a volt amp meter that tells me how many watts is being consumed. Now I want to put this all into an enclosure, and I can't put all of this heat sinking into an enclosure without having some kind of ventilation. So what I've done is I have ordered up a fan controller. So this is a 12 volt 5 amp pulse width modulation PC CPU fan temperature controller, speed controller board. So with this board I can control up to 5 amps of fans, and I can set my points, my trip points. I can, and it has a temperature sensor alarm for overheat. Or no, not for overheat, for turning the fans on, shutting them off. There's an alarm for the circuit in here monitors the fan speeds, and if it drops below 700 the alarm goes off, which is another good thing. So this is a capable little unit, and it only cost me a few bucks, and I think I'm going to implement this into my design to control all of the cooling. Why not, eh? It's only a couple dollars. And for fans, I have tons of fans here I got from servers. These are 60 millimeters, 12 volt fans, another 60 millimeter 12 volt fans. This one draws 1.8 amps, so it's a little high. It probably moves a lot of air. That might not be what I want. I might want something a little quieter and a little more mellow. I might have to go for a pair of these maybe. But we got fans. We got no problem there. We got heat sinking. We got the controller. We have the electronic loads with MOSFETs. I have MOSFETs, big MOSFETs, and they're like $20 a piece. And you can use any N-channel MOSFET on these things. It'll still sync the current. And so I'll have 4 channels with monitoring. And what else? Yeah, I need to put it in an enclosure. So I picked out this enclosure. This one's on DigiKey. I finally went on DigiKey and looked at enclosures because the big roadblock for this project, I have all the equipment or all the electronics to build it, I just don't have anything to put it in. So that was my big roadblock, is I was looking for a suitable enclosure, one that's big enough and you know, it's going to look half decent. This is just a plain old chassis, aluminum chassis, 17 inches by 10 inches, which should be big enough to enclose all of my hardware, and it's 3 inches tall, I believe. For 80 millimeters? Maybe it's 4 inches tall. No, it's only 3 inches tall. So I should have enough room to put 4 meters across the front, plus maybe some switches, a power switch, and some indicator lights for how the fan is doing, and and all that. I haven't decided on all that yet. And then there'll be input banana plugs for each channel. There'll be a 10-turn pot for each channel, so I can control each channel independently, and so on. These aluminum chassis aren't really cheap, but it's actually not too bad. It's $55, which in the US probably it works out to about 30. But you know, why not? I'll spend the coin, get a nice chassis, and have it all done up nice, and it'll look decent. Look kind of it'll still be homemade, but it'll look a little better than using. I was thinking a wooden box, and oh no, I don't want a wooden box. It's just crap. But this will fit, and I think all of my equipment will fit. I'm gonna have 16 inches of these boards. They're all going to be side by side, so that's 16 inches, and that'll fit within the 17-inch chassis. And then the rest of the area can be for heat sinks and fans. To run everything, I have a little power supply here. This is a little dual power supply, switch mode. It has a 5-volt regulator, which I don't need, and I think it puts out 12 volts. So probably what I can do is I can modify this to just do 12 volts only, and if it puts out a couple of amps on 12 volts, that's what all I need. What does it say here? Output. +5 at 1 volt, 5.1 volts at 2.4 amp, and -5 at half an amp. So what I can do is I can go in and I can modify this secondary circuit. I think there's a yeah, there is an optocoupler. So I can go in and I can adjust this to run at any voltage I want, actually, just by fiddling around with the, look at that, that's loose. I have to fix it before I put it in. I can modify the circuit to be any voltage I want, from 5 volts up to 12. I can just make it 12 just by turning up the regulation in there. But that's another story. If this doesn't supply enough power, I can get another power supply. I got lots of these. I think this is out of a DVD player, maybe, or maybe it's out of a satellite box or something like that, where they have the standalone power supply and then they plug it into the main board. So there it is in a nutshell. Looking to build this, and I got this chassis on order. I ordered it today. It should be here tomorrow, and tomorrow I can start drilling the front panel, making room for all the meters and all the switches and knobs, and can start drilling the bottom panel, or top would it be, for the mounting of the printed circuit boards and the heat sinking fans, and then we'll start wiring it up and see how it goes. So anyways, that's what I'm planning on doing. What else do I got to say about this? Oh yeah, power switch. See, I even got a cool power switch. If I can get this to light up, that would be awesome. I think it does light up. Let me read this. Lamp maximum 60 volts, 1.2 watts. Yeah, so it does take a lamp. And let's see. The switch is rated at 5 amps at 250 volts. So this switch is good for being powered. This has a fuse. No, it doesn't have a fuse. I'll have to make sure it's fused. Yeah, it's got a fuse in here. I might remove that fuse and put a panel mount fuse on, so because that one's all gooped in silicone. I'll take that fuse out and I'll put a panel mount fuse. This one's got RFI suppression. Just one of the reasons why I picked it. Yeah, okay, that should work. So I'm kind of excited about this. Let's get tomorrow when that panel comes in, I'll start drilling holes and see what I can do. I'm trying to think about problems I might run into if I have, for example, let's see here. Come on out. Come on. I want to see if I'm going to run into problems with power, for one thing. If this will have enough power to run the fans, run 4 voltmeters, and run 4 load boards. I'm hoping it does. If it doesn't, I'll have to get something bigger. This thing, actually here, let me put it on pause. I'll get a schematic of this. Okay, here it is. The 12 volts input, you can feed it 12 volts AC, and it's got a bridge rectifier. You can see here 4 diodes built into the board, and then it goes into filter caps, and then runs the chip, so it doesn't take much power at all. And I can bypass this bridge and just go directly to the power rail. Here's a little constant current thing going on here, I believe. What is this? This is the 431. And then this is your control, and it controls 1, 2, and goes down here, 3, 4 of these quad op amps. There's 4 of them in here. And each one, output of each one runs the gate of the MOSFET. And there's a 1K resistor there, 1K resistor there, to keep a bit of isolation from the load current to the power current, I'm assuming. That's one thing I was wondering, because if I run a bunch of these in the same cabinet, running them off the same power supply, I don't want currents backfeeding one another. And I guess with these 1K resistors, that should prevent that. And I was also thinking, what if I want to run one of these loads as a negative power supply? I should be able to flip it around and feed it power in backwards to get the, or not backwards, but flip it around and feed power in to get the correct polarity, so that this will behave. I guess it doesn't matter polarity on these. Do plus or minus or the other way around. I'll test them. But yeah, that's it in a nutshell. Like I said, I have 4 of these, and I think I have most of them completed. I have to work on a few more. And then I want to test out how much current this thing draws. I'm going to put that right now. I'm going to turn some power onto this. And let's feed it 12 volts. Okay. 12 volts. It's gone negative. Positive. These garbage alligator clips. You don't want to hold the wire. Okay. You can see it is on. Let me turn the light off. There you go. And it's not overly bright, which is good. It's drawing 30 milliamps, so 4 of these, you're looking at 120 milliamps for the 4 of them. That should be acceptable, so that's good. So yeah, actually I wanted to test this and see. Let's try this one more time. Oh my god. Okay. We have coming out of the power supply 12.5 volts. Let's see what this says. .45, and it's all adjustable, so you know, we can adjust it. But that's going to be good enough. That's going to be good enough for my monitoring purposes. I can monitor how much voltage is coming out or going into the load, how much current, and how many watts it's drawing. That's exactly what I wanted. Is this thing here. and you know, for $2 each or whatever they cost. I think I paid $2, yeah, free shipping. You can't beat it. That was before you could actually buy stuff on Alibaba and have them deliver it to you. Now you're waiting 4 or 6 months because of the coronavirus. But anyways, all right, so tomorrow starts when the panel or the chassis arrives, and I'm going to start doing some drilling, and then we'll get this project underway. All right, thanks for watching.